So this is going to be a quick review of the new definitions that we have for the trigonometric functions. And if you remember, there are 6 trig functions. There's sine, cosine, and tangent, which you have dealt with before. And then there are the reciprocal functions. Right? The reciprocal function of sine is cosecant. The reciprocal function of cosine is secant. And the reciprocal function of tangent is cotangent. If you're given any point on the terminal side of the angle, you can find the sine by taking the y-coordinate and dividing it by the radius, right? The distance from the origin to the point. You can find the cosine by taking the x-coordinate and dividing it by the radius, which is the distance from the vertex to the point on the terminal side. And for the tangent, you can find the tangent by taking the y-coordinate and dividing it by the x-coordinate. And when you look at these definitions, they are not really different from what you're used to. If we think of this as a right triangle here, oops, didn't mean to move that. There we go. If we think of this as a right triangle from here to here to here, this angle right here has a sign of opposite over hypotenuse, y over r, has a cosine of adjacent over hypotenuse, which is x over r, right? And has a tangent of opposite over adjacent, which is y over x. So why do this, you ask? Well, what about the tangent, cosine, and sine of this angle alpha that goes around this way, right? The negative angle. Basically, we want the sine, cosine, and tangent of this angle and this angle to be the same because it makes sense for them to be the same. And with our new definitions, we can do that, whereas with the old definitions that only applied to right triangles, we would have been stuck. We wouldn't have had any way to find the trig functions for this angle here, this negative angle. Let's talk for a minute about how you go about using this. And what's really important for you to know is that as you go through this semester and next semester, the method I'm about to show you for figuring out the trig functions for a specific angle based on a point on its terminal side is going to come up again and again and again and again. You will see it more than once. So it's worth learning. And the sooner you learn it, the better off you're going to be. And good news, okay, it is not at all that hard to work through if you just sort of relax and remember what you already know. So, without much more talking, let me go show you exactly what I mean. Okay, here we are. Okay, here's a problem. The problem is find the exact values of the 6 trig ratios for theta. And theta here is the angle, right, in standard position. Right? Initial side's here, terminal side is here. And the only thing we know is that the terminal side goes through the point -5, 12. That's the only thing you're given here. Now, just to make life a little bit easier, let's think about what we know. We know that this length right here is 12. And we know that this length right here is 5. Right? More specifically, the length of this is 5. The displacement from here to here is actually -5. -5, 12. Since this is a right triangle, this distance right here, which would be the radius, is equal to the square root of x squared plus y squared. Okay, that's the Pythagorean theorem. Easy enough. So if I want to know what r is, in this case, it's going to be the square root of 25 plus 144. Right? Here's -5 squared is 25, and 12 squared is 144. So that means r is going to be equal to the square root of 169, and that means that r is going to be 13. Okay. If you recognized this as a Pythagorean triple, 5, 12, and 13, then you probably didn't have to do this arithmetic. But it's okay if you didn't, because it's easy. Again, it's easy enough. The arithmetic is pretty straightforward. 5 squared plus 12 squared is 169, and the square root of that is 13. So, okay, so now what do? I have all of the values. I have the 3 numbers that are relevant here. All I have to do is write them down in the right spots. Sine is y over r, y is 12, r is 13, so the sine is 12 over 13. The cosine is x over r. Okay, so x is -5, r is 13, so this is -5 over 13. The tangent is y over x, so that's going to be -12 over 5. Okay. The cosecant, where is that? That's up here. That's r over y. Okay. R over y, let's see, that would be 13 over 12. Right. The secant would be r over x, so that's 13 over -5. And the cotangent of theta is x over y, so that's going to be -5 over 12. And that is the answer to the question. And in a little bit, we'll show you how you can go backwards from this to find out what the angle measure is. But for the moment, this is pretty much all you're being asked. Find the exact values of the 6 trig ratios for theta.